person who voted for embedded system to maybe try to explain why? You can raise your hand so that I can unmute you. Just one person. Anyone? Okay. Anyone who voted for general system can say something. Yes, Vanessa.
Wait.
Okay. Yeah, you can talk, Vanessa.
I voted for the embedded system because I think a watch is an embedded system because it performs one dedicated function, which is just to tell time.
Okay. So you put it under embedded. Okay. Anyone for general system? Anyone who chose a general system? Okay. Anyone who chose both? Okay. Anyone who chose none? Only one person. Yes, Naomi.
I voted for both
Okay.
because there's an analog watch, which I think it's an embedded system because it only tells time.
Analog.
And then, yes.
Analog is embedded.
And then there's a digital watch, which can do more than just tell time. Yeah.
So the digital is what is a general system?
Yes.
Okay. Sawa. Yes, Afandi.
I'll say that it falls. Okay, I chose both because there are smartwatches that exist.
Okay.
And yeah, I'll say a smartwatch is an embedded system.
Okay.
Because it performs a specific function, like it aims on, it's either going to show the time or it's going to show if it's your blood pressure, your heartbeat rate, all that. Then
Okay.
if you look like at yeah, okay, that's the only point I have.
Okay. It's okay. Okay. I'd seen someone, I think they've gone. There was someone who had raised their hand. Yeah, Reb.
I think it's a general system as opposed to embedded because embedded would be a dedicated task within a bigger system. But this one, it's just one task that's occurring as opposed to being in a bigger system. So in my opinion, it's just a general system.
Okay. Okay, good. Anyone else? Yeah, so I think in my view, a watch can be both. Yeah, so it depends on which type of watch you're talking about. So if you're just talking about an analog watch, the one with the three hands, then that is a general system because it doesn't have, first of all, it doesn't have a microprocessor, but it does a specific task. You remember in the definition, the one for computer science, we say that an embedded system must have a microprocessor. So that doesn't have a microprocessor. So it just does a specific task. So it doesn't fall under embedded system, but it falls under the general system. Then when you come to smartphones, now there it becomes a little bit confusing because there are some smartphones that are embedded systems, because that means they have, so all of them have microprocessors. There are some that do a specific job and the user cannot really reconfigure it. Yeah. So these are the, for example, the low versions of Fitbit. And so what you can do, it can just do a specific task, maybe measure your temperature and show time, but you can't really modify. It has it gives you little room to modify it. But there are certain smartwatches that are very high end. They allow you to install applications. They allow you to do so many things. So they actually fall under general systems, not really general system, but general computing. They are more of, because now they are no longer doing a specific task. Yes, they are small, but they have very powerful CPUs. They are performing more than one specific task, and the user can actually interact with it and actually modify a lot of things. So really, it depends on how you look at it. So when you ask such a question, for example, in the exam or in the CAT, what I'll be looking at is how you explain your point. Okay, so if you're going for embedded system, then how are you explaining that it's an embedded system? Because a watch can fall under both. Okay, I don't know if it's clear. Okay, so that was, I think most of the people have joined. There is this other one. I think this one will be easy. A smartphone, is it an embedded system or not? Okay, so I think now we can start. I say we have 82 people. I think we are waiting for maybe 20, but I think I'll just start. So today I wasn't going to teach anything. It was you guys to present. So there are basics. I reshuffled, so I hope you've looked at which group you belong to. So there's ICS Group A, which has 5 groups. Then ICS Group B has 7 groups, and then BTC has 4 groups. So today we are going to have ICS Group B, Group 1 and 2. So Group 1 and 2, they are going to present, okay, on the case study. So I'll give each group 15 minutes to present, and then if anyone has a question, you can ask, and then they'll try to explain or justify their answers. So group 1, we have the group 1 that has Tyrone, Marvin, Mwambali, Walter, Victor, Malik, Anthony, Aziz, and Kivuguto. So you are the first one to present. So I can make you a co-host. I don't know how you're going to do it. Do you have any group member from that group? How are you going to do it? Do you want to share your screen, or you'll just like present? Anyone from that group, group 1, ICS Group B? Okay, so Kivai is saying is ready. So Kivai, I'll unmute you. So you have you want to share your screen?
No, I'll just talk over it.
Okay, so everyone can hear Anthony.
Okay, so what is, let me open tab.
So
So
Anthony, you
the,
can start. You can start.
okay, so in the case study, the first question asks is asking about what technology you'd advise Fatma to read on. And since in the case study, she's trying to make we assumed she's trying to make the flower um, continue to grow even in the dry season. I think she would need to do some kind of automation where she doesn't need to be around every single, like, the whole time. So I think she would want to make like a system, an automated system that would just be making the plant grow. So in this case, the technology I'd advise her to read on is IoT, just purely because she wants to do some kind of automation. Now, in the second question, let me look for it. Oh yeah, and the second question it asks if that technology includes an application of an embedded system. So with the Internet of Things, it does include embedded systems. So the kind of embedded system, yeah, so with the system we discussed, the embedded system would comprise of an air temperature or humidity sensor, a device that sprinkles water or just supplies water to the plant, a microcontroller that would analyze the input from the sensors, and a digital to analog converter that I'm thinking is to convert the analog the analog input from the sensors to the microprocessor, and now to convert the digital signals to the actuator, which is the device that will be supplying water to the plants. So I'll leave the rest to another one of my group members to discuss the merits and demerits of the system. So I think you can unmute Walter. Walter will be doing the rest.
Hello, can you hear me?
Hello, Walter. You can raise your voice a bit. You're a bit low.
So, for the merits and demerits of the system, hello.
Hello. Yes, we can hear you. We can hear you.
Yeah. So for the merits, the Fatuma doesn't need to be physically there for the system to work to check on it. Since it is an automated system, the device in itself will be checking whether the temperature is good, if the flowers require water, and such. That is the main advantage. For the demerits now, since this will be an electronic device and it will be out there in the harsh weather conditions such as the sun, the rain, which may affect its working, there has to be some way of protecting the device from the harsh weather conditions, maybe like something like a shade or a protective measure against the device. Otherwise, if it's affected by the weather conditions, it might stop working. Then the temperature and humidity sensor there will be also another problem with power consumption now. Since it's an automated system that works on electricity, there has to be a constant supply of electricity for the for the device to work. If there is no electricity, the device cannot work, and hence it will not be able to perform the activities which it needed to do. Yeah, those are merits and demerits.
Okay. So group one, so you're done, yeah?
Yeah.
Okay, sawa sawa. Anyone with a question? You can just raise your hand and then I'll unmute. Okay, no question. So we'll go to group two. So before I give my comments, we'll go to group two and then we see what they've prepared for us. And then I can give my comments. And then if you have any questions, we can answer them. We can call it a day. So group two, we have Julie, we have Vivian. Okay, let me just share the screen first of all so that so group two we have Julie, we have Vivian, then Tiffany, Megan, Bashir, Ian, Cosmas, Maria, Nicholas, and Solomon. So anyone who is ready, so who is presenting in group two?
Good morning.
Good morning. So that is
For, yeah, for group two, the main problem that we identified before.
You want to share your screen or you okay?
No, I'm okay.
Okay, so you can go ahead.
So the main problem we identified was that the plant was being scorched by the sun immediately after the rainy season was over, mainly because of the increased sunlight and the reduced rainfall. Our initial was to advise her to read more on technology that could be used to create an automated sunshade. This will be implemented using the sunlight that was present and the shade.
Okay, Ian, you're breaking.
Now
Yeah.
this will be considered an embedded system in that. Sorry,
You're breaking. I don't know if it's only me, but you're not smooth. I don't know if you can just start again because I missed some points that you were saying.
okay. The main problem we identified was that the plant was being scorched by the sun after the rainy season was over. And to solve this problem, we wanted to advise Fatima to read more on technology that could be used to create an automated sunshade. This would use Arduino technology to implement the use of sensors to determine light intensity and use it to put the shade up or down. Now, this will be considered an embedded. it involves the use of both hardware and software in order to perform this one specific function, which is to provide shade for this plant during the when the light intensity increases. Is everyone with me?
Yes, we are with you.
Okay, now I'd like to pass on to Solomon to handle the merits of the system.
Is Solomon around? I can switch Julie. Julie, you're ready, yeah?
Yeah, I'm ready.
Okay, you can take over.
Okay, so for the merits, we realized that in this case, we'll need to use less resources because we are performing a specific task. So we'll just need specific resources for this one-time task. And then because we're using it for just one job, we also realized it requires some low maintenance. And also because we are planning to use a system which is small, it will require less space. So that is one of the merits. On the demerits, we realized that some of the equipment can be affected by the extreme weather conditions because in this case you're dealing with rain, sunlight, and such things. We also realized that it will require to use some expensive materials as we start the project, despite the fact that we need to maintain them once in a while. It will require a lot of money to start the project. We also realized that these devices, or rather the hardware, will be exposed to people, and during the whole process, people can mess up with the operation and the setup. So the equipment are prone to be destroyed by people. Yeah, that is all we have.
Okay, so anyone else? So James, you want to say? Oh no, James. So group B. So that's it, yeah.
Yeah.
Okay. So I'll ask one question for each group. So for group one, I just go to the demerits first of all. So you say that the demerits is the power supply. So
Yes.
how can you like minimize on power usage?
Basically, I think if you can try to
Walter,
scale.
this is Walter, yeah?
Yes.
You had presented, isn't it?
Yes.
Yeah, and I want someone else to answer. Aziz, is Aziz around? Aziz? So Aziz is not around. What about Kivuguto?
Yes, I'm around.
Yeah. So how can you minimize on power?
I think since it will be exposed to the sun, we can either use other technologies like solar panel or any other source to use that energy instead of in order to reduce the power consumption.
Okay. The solar panel will not reduce power consumption until it is an alternative source. Yeah.
Yeah, it's one way in which you can direct.
Oh, okay. So good. Is Mwambali around? Marvin? What about Walter?
Yes, I'm here.
Walter, yeah. No, Walter, not you. Victor? Victor, not around. What about
Marvin is here.
Marvin is here.
Yes.
Yeah. How can you reduce power consumption? So solar is one. Any other? But solar is an alternative source. It doesn't reduce.
Sorry. Just a question. Which Marvin are you talking about? Marvin Matata, or there are two Marvins in this class?
Oh, there are two Marvins. Both of them
Yes.
are around.
I'm Marvin Matata. I'm in the group
Okero,
6.
no, I'm
No,
talking of
no.
group one.
Sorry,
Group
that's not me.
Yeah, Marvin Okero.
Okay. Sorry.
Yeah. So Marvin Okero is around, eh? Not around. What about Victor?
Yes, I'm around.
Oh, Marvin. Okay. So,
One of the ways I think that you can reduce the power consumption, you can do something called, you can unplug the idle electronics during like the rainy season and let it away.
you unplug it.
Like at the unnecessary bits of the system during like the rainy season and the plant can survive. You can have
Okay.
the sprinklers off or something. Yeah.
Okay. So.
Hello.
Okay. Who is this?
Hello.
Hello, I can hear you.
Oh, Victor.
Oh, you're Victor.
Yes.
Say something.
Question.
Ask.
Oh, I'm asking if you have a question.
Oh, the same. The one on the solar.
Oh.
On the one on the power supply, how can you reduce? So Marvin says you unplug. What is your solution?
Maybe the program you're going to use, try and make it as efficient as possible to utilize the power.
Okay. How would you make it efficient?
Okay, maybe enable the system to okay, for instance, when you're watering the plant, make sure that the system waters enough plants not to go further than the required amount of water to conserve the energy being used.
Okay, sawa. So that is a good one.
Another, just to expand on that point.
Okay.
To better improve on the power consumption, just like you said, you can make it not be using using the devices such as the sprinkler or the device that supplies the power. Maybe set it off on a schedule, not just making it run all the whole day, something like that. So maybe at specific times you'll be turning it on so that it can reduce the amount of power that is used to power the
You'll be
system.
doing that manually or it will be automated?
Automated.
Automated.
Yes.
Okay. So anyone from group one who wants to say something about power? Okay, so I'll move to group two. So group two, I'll go to the merits. So for the merits, Julie mentioned three, the ones that I could hear. There's less resources, low maintenance, less space. So all these three just point to one thing. The system is constrained. So it's really one merit that is just expounded into 3 points. So is there any other merit you can add? So group 2, we have Vivian, Tiffany, Megan, Bashir, I'll skip Ian, Cosmos, Maria, Nicholas, and Solomon. Any other merit you can add? So Vivian, we can start with you.
I think another merit, I don't know if you guys can hear me.
Yes, we can hear you.
I think another merit could be probably if it's an automated system, you won't have to manually do the work.
Manually do the work. Which work is that?
For example, it's a sunshade. You won't have to probably monitor it or yeah.
Okay. Tiffany? Tiffany is not around. Megan? Megan? Bashir? Okay, then we have Cosmos.
Yeah, I'm around, sir.
Oh, this is who? Bashir?
Bashir, yeah.
Okay. Any other merit?
So I think you can say that for the merit, like it's on one of the characteristics which we talked about, which was reactive, which is always on. So it's always available for responding to the changes, right? So then we can say that the system is always going to be available whenever it is required, and then like whenever it is not required, it can be put to rest or something like that.
Okay, so that's good. What about Cosmos?
Hi. So, can you hear me?
Yes, we can hear you. Just raise
So
your voice a bit.
okay. So on my part, I thought we could talk about customization where you could put a schedule to turn it on or off the shed at different times of the day.
Also, you can have a schedule.
Yeah, maybe you could customize it to turn on at some point and turn off at some point. So it's highly customizable.
Okay. Maria?
Hello.
Hello.
I think I would say it has a low operational cost because it's only doing one particular thing and it's only operating on a small space.
Okay. So the cost is in terms of it uses less power, or it's because it's using less space, physical space? That's what you mean?
And I think it also uses less power.
Okay.
Yeah.
Okay. So it's cheaper.
Yes.
Okay. Though I don't really understand how. Is there an alternative for monitoring the shade that is more expensive, so that this one is cheaper? Or is there another system you can compare to and say maybe if you use this, it will use more power, but ours, because it's using ABC, it uses less power?
I think I remember from group one, they also mentioned that it would use solar power. So if you're to input solar power, you'd use less cost on operating it.
Okay. But that is an alternative source.
Yeah.
Anyway, Nicholas?
Yeah, present.
Okay.
Okay. Oh, okay. More on the expansion on the power efficiency, right?
Merits, no.
It could use batteries, and act like how a TV remote is always available. The power is always there unless, you just need to press the button and it will work instantly. So by using batteries, it could always run 24/7, and they can even be rechargeable since there's solar energy and all that.
Okay, Nicholas, we are talking about the merits. not
Yeah.
solar.
Hmm.
So any other merit? You're not talking about power. Any other merit for your that your system will have on the user?
Okay. No, I don't think there's any other I could think of.
Okay, sawa. Solomon? Okay, so Solomon is not around. Anyway, so just to give my comments, for group one, I noticed that quite a number of members. I don't know if you did it as a team or just one person did it and then you presented, because quite a number of members were not present. Group two also, anyway, group two, it's only I think one or two, but group one, there was a lot of no group work. So that is one comment. Then the other one is on basically your presentation and your answers and everything. So I'll start with the one for the merits and demerits. So, for example, such questions, for example, they might come in the cut, and I would prefer you look at the characteristics. So you derive your merits from the characteristics of that we discussed in class. Yeah? So, for example, where are the characteristics? Let's see. So you can derive, you can get a lot of merits from the characteristics of an embedded computing system. Okay, so because it's single function, you can now add your merits there, dependable. So you can get a lot of merits here. Okay, and also here you can also look at it on the negative side, and also you can get the demerits. Because, for example, if it allows no user corruption, it means if the user wants maybe to do a particular customization, they can. So that's a demerit. Okay? So I would prefer you formulate your merits or demerits from the characteristics of the embedded computing system. So that is for number 3. Then for number 2, okay, listen. Okay, can I just go to the rest? So for number 2, I think both groups did well, because the idea was I wanted you guys to link your solution to an embedded system, which I think for group 1, yours was for automated, I think it was humidity. You're doing something to do with a humidity sensor, but I didn't really get how your system was working. For group 2, it was basically the shed, controlling the shed. So I think question 2 was fairly answered. For question 1, I think, anyway, I think this is the first case study, but I feel like it wasn't, you didn't actually look at the technologies, you just gave a solution. Because what I was thinking was, for example, you can look at smart gardening. There's a gardening that can be done just next to, just behind your backyard. Yeah. So, for example, this one. So you could have maybe encouraged Fatma to read on this smart gardening. So what is it about? How does it work and everything? So from here now you try to look at the characteristics of this. So how does it work? What are the features? So is a smart garden an embedded system or a general system? I don't know if it's making sense, but maybe for the other groups, maybe you can try to look at it from that point of view. Okay. So I think that's it. So I'll award marks for those two groups. So any other question? So I can see group 3 and 4. I think BTC groups, they have a problem. So I think what we do is so for BTC, if you have a class rep, maybe what you can do is just put the right groups and then you send it to me through the email. So the class rep should just consolidate all the groups, because I think I've seen a text here. Maybe some groups are not the ones that are supposed to be there. So BTC group. So maybe you can have your class rep work on that, and then they'll send to me the correct list of students. Then Afandi was asking, I think Afandi, you're asking a question if I can elaborate more on the general systems. I think there are three things maybe that I mentioned that may be confusing. So there is the embedded systems, then general systems, embedded computing system, then there's the general computing system, and then there's the general system, okay? So for embedded computing system, you're basically talking of a system that is single function. It's microprocessor based, but it performs only a single function. It's just um, it's designed to work on a specific task. Okay. Then for general system, it's general computing system. Sorry, it's a microprocessor based, but it's not designed to focus on a specific task. So the user decides which task to perform. So they can do so many multiple tasks, maybe even simultaneously. Then a general system, this is, it's not computing, so it doesn't have a microprocessor. So for example, an analog watch, that is a general system. So these are systems that are not microprocessor based, but there's sort of a logic behind how they work. So for example, an analog watch, it doesn't have a microprocessor, but there's a logic on how the shorthand moves, the second hand moves, and then after 60 seconds, the minute hand moves once. So there's some logic around it, but it's not being implemented by a microprocessor. I don't know if it's clear now, Afandi, or to anyone who didn't understand. So the difference between the three. Yes, Anthony. Anthony, you can speak.
Oh yes. So when you explain the difference between the general purpose and embedded systems,
Yeah.
is the difference in whether it has a microprocessor or whether the user can configure, can do their own stuff with it. Like, is the difference in specifically one of those areas? It's a wide-ranging thing.
The difference is in those areas. Yeah. So, for example, an embedded system, it's single function, and the user cannot change anything. Yeah. Then a general purpose system, it does not even have a microprocessor, but there's some logic. Okay. So it's single function. Yes. For example, an analog watch, it's single function, but it doesn't have a microprocessor. Then you have a general computing system. This one has a microprocessor, but it's not single function. So the user can do so many tasks. They can actually modify, they can configure it to their liking.
So in the two examples you've just given, can you classify each of them individually? Like, this is a general purpose and this is an embedded system.
Yeah. An analog watch is a general purpose. A smartwatch, let me say a Fitbit watch is an embedded system, and then your laptop is a general computing system. Then Ayan, you have a question?
So on the general purpose systems, what is the time complexity when running different simultaneous tasks? Is it
does it take more time, or is it just the same as a system doing one function?
Which one? The general purpose.
Yeah.
What is the time complexity in terms of?
For both, what would you say is the difference? Does it cost much? Does it take much more time?
Oh no. The difference is the difference. So for general purpose, basically the only thing that classifies it as a general purpose is because it doesn't have a microprocessor. So it can take a shorter time, it can be very efficient, it can be less efficient, but it's not microprocessor based. The way it makes its decision or the way it works is not microprocessor based.
I was talking about general computing, sorry.
Or general computing.
Yeah.
Or no, time complexity is not a problem. So it can be slow, but as long as the user can configure it and do like whatever he wants to his liking, then it's a general computing system. So it can be slow, it can be fast. The only thing is that the user it allows the user to actually reconfigure, maybe run so many things according to his own liking. I don't know if it's making sense. I am.
It does make sense.
Okay, so Julie, you had a question? I think I'll take maybe one more from Julie. Also clarify on the analog watch. So I said the analog watch is a general purpose system because it runs, so it's single function, yes, it shows the time, but the way its logic is not based on a microprocessor. So it's based on the hands. Okay, so you have the seconds hands just running, and then when it reaches 60, the minute hand moves by one. Okay. And when I talk of analog watch, I don't mean that one that is digitally controlled. You see, there is, for example, you can have a smartwatch and then you configure it to show the analog. So I'm not talking about that. I'm talking about, for example, this one that's on my wall. I don't know if you can see it. This one here. This is a general purpose. That is what I mean. I don't know if it's making sense. Okay, so I think we can stop there for today. So next week we'll start on the second topic, and then yeah, we'll proceed from there. Okay, so you guys have enjoyed the rest of your day. Stay safe and minimize your movements. And yeah, okay.